Hello learners, welcome to Education Online program. I'm teacher Willa Lucia. So in our previous lesson, we talked a lot about linear motion, which we defined as the motion in a straight line, and sometimes it's also known as a rectilinear motion. So under that, we looked at the velocity, we looked at things like speed, acceleration, how they are defined, their SI units, so many things under linear motion. So you'll find out that the velocity, all those things are summarized in something known as the equation of motion. So there are basically three equations of motion. So today we shall be looking at those three equations of motion. We shall look at how they are, and we're going to see how we can derive them so that we come up with that equation. So what is the first equation there? Let me give you this. So we shall have it as equation of motion. So this equation of motion here summarizes everything we talked about, most especially those terms we use in linear motion. They summarize all of them in this. So the first equation we're talking about is like this. We have it as final velocity is equals to initial velocity plus acceleration and then the time. So if you look at this equation here, in our previous lesson we said V is a letter given to final velocity attained by a body. So if we talk about the U, we're saying that it is the initial velocity. The velocity that the body starts moving with is what is known as the initial. So at what rate is your body accelerating? So acceleration, we are giving it letter A. So with that we also have the T. That T stands for time. The time the body has taken to move from one point to another. So that is the T. So this is how our first equation of motion looks like. So let's look at the second one. How is it like? So we have the second one as S. S is equals to a UT plus a half AT squared. So that is our second equation of motion. So what is S standing for? So our S here represents the distance, or you can also call it the displacement. When they want you to find the distance a body moved, so they are meaning you find the S. So when you look at the T, we already say that T is the initial velocity, the velocity with which the body starts moving. So we've talked about the A, which is the acceleration, and the T is standing for time. So we have our third equation of motion as V squared is equals to U squared plus 2AS. So if you look at this equation of motion, it looks all the three actually don't look alike, because if you look at the first equation there, we are having the final velocity, we have the initial velocity, we have acceleration, and then we have time. So what is lacking in our first equation of motion there? You find out that in the first equation of motion we don't have the displacement, which is known as the distance. So now you come to the second one. The second, you'll see that there is time, there is acceleration here, we have the initial velocity, but we have the S, the distance, which is also the displacement. So what is lacking in this equation, the second equation, if you take a look at it? So if you look at our second equation there, we don't have the final velocity. the velocity with which the body comes to rest. So it is not in this one. This is the thing that makes the first one different from the second one, is that the first one has final velocity, which is the v, but then the second one doesn't have the final velocity, but then it has the distance moved, which is not the case with the first. So look at the third one. In the third one, we have the final velocity, we have initial velocity, we have the acceleration, and then we have the displacement. What is lacking there? The time. When you take a look at this, there is no the element of time in this equation here. So this is how the three of them differ from each other, because each one at least lacks what the other one has. They don't have the same things. So we are going to see how we shall come up with all this. So that we don't get confused, let me summarize for you these letters. I'm going to write for you the letter and then writing it in full. So that means that when you look at v is equals to, let me put it this way, whereby v is equals to final velocity. So we have u, which is the initial velocity, and then we have our a, which is the acceleration. Some people mostly try to call this acceleration due to gravity. Acceleration due to gravity is being abbreviated by letter G. So this one is just acceleration. Acceleration due to gravity is G. So what other element do we have here? We have the T, which is the time. Then we have the, what is lacking? We have all this. So we have one thing left out, the S, which is the displacement. Sometimes it's known as, you can also call it the distance. So you see that our velocity is measured in what? The unit for velocity is meters per second. This is initial velocity, is the same as velocity, again in meters per second. So we have acceleration, which is in meters per second, per square second, like that. So we have the time is measured in seconds. Our displacement, or the distance, is always measured in meters. So now we have seen the abbreviations and we have known their SI units. So now let's go to this very interesting part here, which is the derivation. We shall have it as a derivation of the equations. Of motion. So when you're deriving these equations of motion, it is the first equation that will lead you to the second, and then will lead you to the third, because there is an element you will need from the first equation, so that you can substitute it in the next equation. So let us look at this. How do you come up with the first equation of motion there? So you find out that to get that, let's talk of a body that is moving. So if we have a body that is moving with a velocity, v, and then it accelerates at a rate of a meters per second squared in time t. So let us have it here in written form. We are considering a body moving with a velocity u and accelerates. Okay, our u is in meters per second, so let's not forget the unit in meters per second, and accelerates at a rate of a meters per second squared in time t seconds for a displacement s meters. So if we have it like that, how would you find this? So you'll see that when we are considering this body, we already know that the body started moving with a velocity which is known as the initial velocity, given to you there as u, and then we know that the body accelerates at a rate of a. So we have our acceleration and we have the time. We also have our displacement, which is s. So how would you derive the first? Let's look at this. From the first one, to derive the first, you have to get it from the definition of acceleration. So we say that in the definition of acceleration, we say that acceleration is the rate of change of what? Of velocity with time. So you'll find out that acceleration is equals to the rate of change of velocity is when you subtract the initial velocity from the final velocity, then you divide it by the time taken for the body to move with that velocity there. So we're going to say that we shall have a is equals to what? V, which is the final velocity, minus our u, the initial velocity, over t. So this is how you summarize the definition of acceleration in mathematical form. So if you have it like that, what do we want there? We want the v to be the subject, because we want our equation to look like this. This is the first one. We are deriving it. So if you look at this, we have all these elements right here in the definition of acceleration. So what we do is, now we get this and we cross multiply to give us a is equals to v over u. This is over t. Then we can change this and make it a fraction, so that we can divide it, we can cross multiply it. So we can divide this by 1. So if you divide it by 1 there, so here we have changed it in a fraction form, and we are able to cross multiply now. So when you cross multiply, this number here, this letter here is going to multiply with the downer one, and then this one here will multiply itself with the numerator that side. So what happens is we shall have our AT is equals to this one. We're multiplying it, so we have it as our A times T is equals to this one will multiply that number up there. We shall have 1 times, because here there are two figures, we shall put in bracket v minus u, so that it can multiply throughout. So we shall have a times t, which will give us our at is equals to, when you multiply any number by 1, what happens is that the number remains itself. So we shall have it here as our v minus u. So if you have it like that, we are almost close to coming up with this equation there. We shall have it now as so we collect this, we bring this u this side, so that we make our v the subject. So if in making the v the subject, we shall have it this way. We shall have our at we are adding this v on both sides, the u I mean, which is u plus at is equals to v minus u plus u. Because if you add it on both sides like this one here, this number and this, because this is a negative and a positive, this u will cancel with that u. So giving us only u plus at is equals to our v, because this side we are only left with a v. So we shall have it, our v is equals to u plus at. So this is our, this is the first equation of motion. So this is how we come up with our first equation of motion. So what we do is you have to know the definition of acceleration. When you interpret it in mathematical form, then you work it out. You will come up with that. So what of the second equation of motion? We have it here as our s is equals to that, but I'm going to rub this side so we can put it somewhere else. We can try to write it somewhere so that we follow it up. So our second equation of motion we want to derive here is, the second one is s is equals to ut plus a half a t squared. So that is what we want to come up with. So let's see how we are going to do that. So to find that, the second equation of motion, for it we are going to use the displacement. So you define the displacement and interpret it in mathematical form so that you come up with that equation. So what did we say is our definition of displacement? We say that it was the rate of change of, it is the distance covered in a given time interval. So if it is like that, to find it here, we are going to get the distance, which is the displacement. We know how it is found. Displacement is equals to what? It will give you, so you multiply that by the time, so that you get. So but this time round we are going to use the average what? We shall be using the average velocity to find that. So how do you get the average velocity? From our previous lesson, I remember saying that to get the average velocity, you add the two velocities. The velocity with which the body starts moving, and then the velocity with which the body comes to rest. You divide that by 2. That is how you get the average velocity. So then if you have the average velocity, you go ahead and multiply it by time, because now you need the time factor there, the time with which the body was moving from the point it started up to the point it came to rest. So let's look at this. We have, from the definition of displacement, we shall have our displacement is equals to average velocity times time. So if we have it like that, our displacement, we said it is abbreviated as s. So we are going to, instead of writing the whole word as displacement, we shall use the letter s. So we shall have our s is equals to average velocity, which we said is you add the two velocities, the final velocity plus the initial velocity, divide it by 2. So if you have it like that, remember we multiply the average velocity with time factor there. So we have it times our time, which is t. So if you have that, what happens is that if you look at this formula here, at that equation there, it doesn't have what? The final velocity. So what we are going to do is we want to eliminate this v from this formula we have written, so that we can come up with that. So to eliminate this, how will you eliminate it? If you'll go back to our first equation, you see that we have the value of v as u plus at. So we shall eliminate it that way by substituting its value there, right here. So we shall have it as our s is equals to, instead of writing v, you write this, but our v is equals to u plus at. So we are substituting it with that value. We shall have here u plus at. Remember, it still has that u there, so we add it plus our u is equals to 2 times our time, which is t. So when you work this one out, what happens? We have u, and then we have u here, and then if you have u and you add the 2, what will you get? You'll get 2u. We are not multiplying. If we were multiplying, we shall get u squared, but this time we are adding. If we are subtracting, we shall get 0. So this one we shall come up with u plus u. Let's first collect the like terms so that we don't get confused. U plus u here, then plus our at. This is dividing it by 2. Multiply it by your t. So if we get our u plus u, we shall have it as 2u plus 80 times our t all over 2. Now we are multiplying this t. So here, what do we have? We would have cross multiplied and brought this one here, but we cannot do that because we want s to remain as our subject. So we shall have something like this. Since you have 2u plus 80 times t squared, what do? We shall have our s. Let's put this in bracket so that we multiply our t inside the bracket. So we shall have it as, this t here will multiply each and every number in the bracket here. So we are going to get, you multiply t and this u, 2u, then you multiply this t again by 80. So you'll see that 2u times t will give us 2ut plus, then you multiply this t again by this other one here, which is 80. So you get 80 times t, we shall have a t squared. This one here is still over what? Divide by 2. So we are going to divide this by this denominator, and then this one we are separating the 2 instead of combining it like that. We want to divide them separately. So we shall have our 2ut divided by 2 plus 80 squared divided by 2. You'll see that our ut here has 2 already here as its coefficient. So when you divide it by another 2, this 2 here will cancel with that 2. So we shall be left with s is equals to ut. Okay, let's make it more clear. We shall have our s is equals to ut, because this 2 will cancel off with that, then plus our coefficient of 80 squared is 1. So when you divide 1 by 2, what will you get? You will get a half. So we shall have our a half here is 1 over 2 a t. So you'll see that at the end we are having this already. So when you look at what we've come up with here, is the same as that. So this is our second equation of motion. So the thing here with the second equation of motion is that you try to find out which element, or what is that thing that we don't need in our equation. So if you get to know the thing we don't need it in the equation, in the final equation, you start eliminating it. So when you eliminate it, you'll see that you'll come easily to your answer. Because for this case here, we see that our second equation of motion doesn't have the final velocity. So we eliminated it by substituting its value we got in the first equation. So in the first equation, this is the formula, the value we got for v. So we just picked it and substituted it right here. So when you substitute it there, you do the math, you'll come up with your the second equation of motion. So now we are left with one other equation of motion, which is normally known as the third equation of motion. Let us try to rub this off. And then we see how we are going to get the third equation of motion. We put it as the third equation of motion. So what is our third equation of motion? This is what we want to come up with, which is v squared is equals to u squared plus 2a plus 2as. That is what we want to come up with. So if you look at that equation there, what is it that we don't have there? We see that we have the displacement, which is the s, we have the acceleration, which is the a, and we have the u, or the initial velocity, but we don't have the time. So then, how shall we eliminate the time from that? So you'll see that to get that again, we are going to use displacement again. The first one we used, we got it from the definition of acceleration. The second one we used displacement. The third one we are still going to use a displacement. So how can we get that from displacement? Since we say that our displacement is equals to, we are getting it from the average velocity multiplying by the time factor there. So our displacement is s, our average velocity is what? Our average velocity is v plus u all over 2, and we are multiplying it by the time factor by t. So now if we look at our equation here, what we need to know is that here we need to make our v, the final velocity, as the subject. So when you're making the final velocity as the subject, what other element is there don't we want in the equation? So you'll see that in our equation there, we do not have time. So we have to eliminate the time as earlier as possible. So as we eliminate it, then we make that the subject, the v the subject, you'll see that you come up with your equation, just that simple. So how do we eliminate the time? You go back to your first equation. So we shall say from first equation, what did we have as our first equation? We had our v is equals to u plus at. So if we have it like that, we can easily eliminate the time. Now we use the first equation. We make the time there the subject. So if we make time the subject, that means that we are trying to find the value of time. So the moment we get the value of time, we come and substitute it in our formula. Then we see. So let's look at this. We make this the subject. How do we make it the subject? By eliminating this. So we shall bring u this side by making it as v minus u is equals to, we are subtracting u from both sides. Here we shall have u minus u, then plus our a at t. So when you get u minus u, you'll get 0. So we shall have our v minus u is equals to a at t. Now this time round we have here the coefficient of t being a. So we don't want the t to have coefficient of a, but we want it to have at least coefficient of 1 only. So we shall divide through by a, and also go here, divide it by a. This one will go with that. So if that cancels, we shall be left with v minus u over a is equals to t. So that means that our value of t is v minus u over a. So we are going to get that value we have there, and then we come and substitute it right here in our formula where there is t. Instead of writing it t, we write v minus u over a. Let's see, this is how it will be like. So we have our s, which is equals to v plus u over 2 times, instead of having this t, we are writing v minus u over a. We are eliminating our t. So if you look at this, we have already eliminated the t, because in our equation here, we did not want the t. So if you have eliminated it, now let's do the rest is mathematics. So we shall have our u plus our v. We shall have our v plus u. Then we have down here, this one, let's keep it in the bracket still, so that we can try to multiply it with that. So what is going to happen is that we can multiply the denominators direct. So if we multiply the denominators, we multiply, okay, one bracket with the other. So what shall we have? If we multiply the denominators, we shall be having our s is equals to v plus u, this is in bracket, times v minus u into bracket, this is all over 2a. So if you look at this, some people will look at v plus u and then v minus u, they will want to cancel it. We are not cancelling anything because we are multiplying it. So how do we do it? We can open this bracket by multiplying each term here in this bracket with the terms in that bracket. So we shall be having our s is equals to, you first get v and multiply it by every term in this bracket. So we shall have our v times this v. Then we have this, we shall still have, if you get v, you multiply it by negative u. That negative value remains there, because if you multiply a negative by a positive, you are going to have a negative. So this negative here dominates and it suppresses the positive. So we shall see that when you get v times negative u, we shall have here negative u times our v, then plus, we are getting, now we are finished with this v, now we are getting our u and multiply it by each and every term in this bracket. So we shall have our u multiplying it by that v. We shall have it as u times v. Then you get your u again and multiply it by negative v or negative u. So we shall have negative u times u. All of this is over 2a. So if we have it that way, let's see. We have v times v, which will give us v squared. We have our negative u times v. What shall we have? We shall have u v, then plus v times u. We shall have u v again, and then we shall have minus, we have u times u, which is u squared. the whole of this is over 2a. So if you have it like that, let us try to make s a fraction by dividing it by 1, so that we cross multiply. So when you divide it by 1 here, we shall cross multiply. What shall we be having? We shall get s times 2a, which will give us 2as is equals to 1 times all these terms will give us this, because when you multiply any number by 1, it doesn't change. The value remains the same. We shall have it as v squared minus uv plus uv minus u squared. If we look at that, we are very much close now, because we have eliminated the time. You can also see that we already have the v squared, which we need. We have the u squared that we need there. We have the 2as that we want also. But what we don't want here still is the uv. So we are going to eliminate the uv. So how do we eliminate the uv? Let's come this side and see that. So when we have our 2as is equals to v squared minus uv plus uv, then minus u squared. I am getting this just from what we calculated right there. So if we have it like that, so we want to eliminate the uv. How do you eliminate the uv? We have negative uv plus uv. It's the same as negative. If you have negative 2 and then you add a positive 2 there, what happens? You'll see that these 2 will cancel. You'll get your answer as that. So meaning that this negative u and the positive u will cancel out, leaving us with 2as is equals to v squared minus u squared. But then we want to make our v squared the subject. How do we make it the subject? By leaving it alone on one side of the equal sign. So what we are going to do is we are going to bring our u right here by adding it in both sides. So we shall have our 2as plus u squared is equals to v squared minus u squared plus u squared. By adding it on both sides, we are trying to take it from one side to the next side. So what shall we be having? This one will go with that. So we shall be left with v squared is equals to u squared plus 2as. So this is our third equation of motion. So now we have seen how we come up with those equations of motion. What you have to know is that from the first one you need to get from the definition of acceleration. The second and third you get from displacement. But for the velocity part of it, let it be the average velocity. So you try to eliminate what is not needed by using the first equation of motion. You get the term from there. So with this, we are going to end with our lesson for today. We shall meet again with more in equations of motion in our next lesson.